So, welcome back. Like I record these videos and then life happens and went and did some stuff with my family. And now I'm back and it's, I don't know what time it is. It's that time. So it's time to do another video. Here we go. We're going to learn about point estimation. So what we've learned about so far is we learned about sampling and sampling distribution. And we learned about, some terminology. Element and is the entity on which data is collected. Population is all of the elements of interest for what we want to collect data about. And then the sample population is the population that we actually sample when we do a sample. But if we do the whole population, we do a census. So what is a sample? A sample is a subset of the population, and the frame is the way that, like here's the frame, and that's where the sample will be selected from. So it's the framework that we use to determine, like, where are we going to be pulling our sample from. And then inferential statistics, that's like we do a sample so that we can make inferences about the population. That's inferential statistics. So we learned that terminology, and then we learned about selecting a sample if it's a finite population or an infinite population, and randomly how do we select that sample. What we're going to learn about now is point estimation. So really some new vocabulary here, and then we'll see a little bit of an example. But point estimation is a form of statistical inference. And so really what this is talking about is like we have a sample and then we're going to make inferences about the population. And so the point estimates, and so you can see a point estimator, point estimator, point estimator, point estimates. We have the sample, and that's going to be an estimate of the population. And so X bar is the point estimator of the population mean U. S is the point estimator of the population standard deviation. And we have that here in our diagram. And so here we have our population, and then we have our sample and the different notation. And so X bar is what we use to refer to, when it's a sample, and mu is what we use to refer to when it's population. So here's the mean. If it's a sample, we say X bar. And if it's a population, we say mu. But we say that the X bar, right, the sample, is a point estimator. The sample mean right here is a point estimator of the population mean. So it's just a new word for stuff you already know, right? That, the sample mean is a point estimator of the population mean. And if we have a variance, this is what the notation is for variance for a sample and variance for a population. And the sample variance is a point estimator for the population variance. The sample standard deviation is a point estimator for the population standard deviation, and so on and so forth. So here you see X bar is a point estimator for the population mean. S, which is the sample standard deviation, is a point estimator for the population standard deviation. And then we have a new notation here, which I need to add to my list, which I have a list right here, so maybe I'll add it and take a picture. But P is the point estimator of the population proportion P. So I'm actually going to do this right now, just add it. Hold on. All right, I'm back. It's really different having kids as opposed to other periods of your life. It's great. It's wonderful. But it just changes things. Like I went out to take a picture of this thing. Here it is with the new notation. I added the proportion for the sample. That's the notation. For the population, that's the notation. And then I was like, okay, bedtime. So do bedtime, come back. Now I'm ready to do this. All right, so I'm not quite sure. We were talking about the point estimator, and it's really stuff you already know, that these things are point estimators for the population, right? For the different metrics here of the population, different statistics of the population. So that's point estimation, stuff we already know. Here's an example. 2,500 employees. We do a simple random sample of 30 employees, and corresponding data on, this is the data on annual salary management training. So this is out of 2,500 employees, sample 30 employees randomly. And this is their annual salary, and this is whether or not they've taken the management training program. And this isn't, there's two fields, right? There's two elements. For each element, there's two characteristics of interest, which we're looking at. And it's annual salary management training program. So here are the first 10 elements. Here are the next 10 elements. And then here are the next 10 elements. You can see that each of these columns, annual salary management training program, repeats. So that's the data. With that data, we could calculate the sample mean, the sample standard deviation, the sample proportion. And a proportion is just like how many people out of all the people did this or did that or whatever. So here's the mean. We add up all the, salaries. I guess this is what it is, 71,000. Add them all up and divide by the total sample. And so this mean is a point estimator. The sample mean is a point estimator of the population mean. And here's the standard deviation of the sample, and it's a point estimator of the standard deviation of the population. And this is the variance right here inside, and then take the square root of the variance gives us the standard deviation. And so the variance is how much does each data point vary from the mean, and then we square that to get rid of negatives, and we add it up, and then we divide by n minus 1. And once we get this total here, we then take the square root and we get that. So there's your standard deviation, the standard amount that the data deviates. And then here's the point estimator, right? How many people have completed the management training? 19 out of 30. So that this is the sample proportion point estimator for the population proportion. And it's 19 out of 30. So, stuff we already know, point estimation. And then you could see here, if this is the sample, the point estimate, and then this is the parameter value. So parameter is like, we refer to a population as, the data that we're looking at is the population parameter, and then this is the sample point estimate of the population parameter. And so this is what we came up with our sample. And then in reality, if we were to look at everybody in the population, we would get these figures. So you can see that they differ a little bit. And as we go through the course, we're going to see how to develop levels of confidence, or what is the confidence interval, or that we could say that, yeah, our point estimate, our sample is close, going to be close to the population parameter plus or minus a certain amount. So just some more vocabulary here. The target population is the population we want to make inferences about. The sampled population is the population for which the sample is actually taken. To me, this is just unnecessarily adding extra vocabulary, because we're talking about a sample and we're talking about a population. And so we could say, hey, it's the sampled populations, the people that we sampled. And then here, that is going to give us allow us to make inferences about the target population, right? So the population we make inferences about, and the population from which the sample is actually taken, the sample population. Whenever a sample is used to make inferences about a population, we should make sure that the targeted population and the sample population are in close agreement, right? Because if our sample doesn't represent the target population, then our sample is not going to give us a good estimate, a good point estimator, point estimate or point estimations about the population. All right, so that's point estimation.